In this video, we're going to talk about solving radical equations. So these are equations that have radicals in them, like square roots or cube roots. To solve these, you have to remember what we talked about with the basic rules of radicals, and that would be that square root and square, okay, remember those are opposites. You can remember that square and square root cancel out, or you can remember this in terms of a rational exponent, and then we multiply the exponents. Okay, so you can either remember that they cancel out, or you can remember that we multiply exponents. Either way, when we have square and square root, we're going to end up with just x. Same idea, cube and cube root. Remember that cube root of x is the same as x to the 1/3. So cube and cube root will give us just x as well. So if you take something and you have got square root and then square it, or cube root and then cube it, those are going to cancel out, and you're going to get that something that was underneath the root. Now, it doesn't just have to be x. We could have something like x plus 5. Okay, that's all underneath the square root. So we have something square rooted and then squared. They happen at the same time, and that's going to be the same idea. They're going to cancel out. Okay, so square and square root cancel out if they happen at the same time. And what I mean by that is if I have square root of x plus 2 squared, now the square and square root cannot cancel out because of this addition here. Okay, remember we cannot distribute exponents over addition or subtraction. So I cannot distribute this exponent. We're going to see this in just a minute. We would have to multiply this out and FOIL this. So let's go ahead and see what that looks like. I think this is a review of the multiplication section. So we'd have first, outer, inner, last. So we'd have square root of x times square root of x. Again, square root of x times square root of x is just x. We'd have plus 2 square root of x, plus 2 square root of x, plus 4. So that would give us x plus 4 square root of x. We can put these together because they're like terms. I've got 2 square root of x and 2 square root of x. That's 4 square root of x. And then plus 4. Now, we really can't combine any terms here because you can't combine square roots with regular numbers or variables. And I can't put together the x plus 4, but we would usually put together anything that's not a square root to the front and then put any square roots at the end. Okay, this answer would be fine with me. A lot of times you'll see it written the second way, though. Just a little bit more proper. Not a huge deal, though. Okay, so this is the idea. If we have square and square root, they're going to cancel out. So let's look at a few examples. Let's start with something basic. Let's say we've got square root of x. Square root of x equals 6. So if I want to solve this, if I want to figure out what x is, this one you could probably look at and figure it out. But if we wanted to solve it, we would do the opposite. And the opposite of a square root is a square. So I would square both sides. Okay, now I've got to square the whole left-hand side and the whole right-hand side. Exponents do not distribute, so we can't do them term by term. It's got to be the whole left and the whole right. This one's pretty straightforward. We've got square root of x squared is x. And then we've got 6 squared is 36. So x is equal to 36, and we could probably see that right here. Square root of 36 is 6. Okay, but that's the basic idea. The same idea applies if we've got cube root of x. Let's say that we've got, hold on, let me go find my right paper here. Okay, let's say we've got cube root of x is equal to 4. So I would want to do the opposite here. The opposite of a cube root is not a square, it's a cube. So I would do the opposite. I would cube both sides, and I would get 64. And then come back up and check. Cube root of 64 is 4. We know that one. And so that one's good. Okay, so let's keep going. What if we have cube root of x equals 2? Okay, cube root of x equals 2. I would do the opposite to both sides. So I would cube both sides. Cube and cube root cancel out, and I would get 2 cubed, which is 8. Cube root of 8 is equal to 2, and that checks. Okay, now what if I had cube root of x is equal to -3? Cube root of x is equal to -3. So again, I would cube both sides. and I would get on the left, cube and cube root cancel. And on the right, negative 3 cubed would be negative 3 times negative 3 times negative 3 would be negative 27. Does that check? If I put it in here, cube root of negative 27 is negative 3. That's okay. Remember, we can have negatives for cube roots and cubes, so that one is okay as well. All right, now, in that same line of thinking, let's try one that's similar with square roots. So let's say that we've got square root of x is equal to negative 2. So like we did before, we would square both sides. And we would get x is equal to 4. But let's write out the check for this one. We've just been doing it in our head. When we go back and we check in the original equation, is the square root of 4 equal to negative 2? When you're given a square root, we haven't done taking square roots yet. When you're given a square root, it's whatever sign you're given. So the square root of 4 is 2, and 2 is not equal to negative 2. And that should make sense from the very first line. We cannot have a square root equal to a negative number, not in the real numbers. So when you see this, square root equals a negative number, right there you stop, and you know that that's no solution, or in your homework that's usually DNE, okay, or no real solution. Okay, so we can't have square root equal to a negative number. We can have cube root equal to a negative number. So we already knew that, but that's a good review. And we also have to remember that we have to check these. You can do everything right and end up with a solution that doesn't work in the original equation. So we have to check these. All right, let's try another one. Let's say we've got square root of x plus 5 equals 4. Okay, square root of x plus 5 equals 4. It looks a little bit more complicated, but it's the same idea. I've got square root is equal to a number, so we're going to square both sides. All right, on the left-hand side, we talked about this a little bit. Okay, we've got something going on here, but it's still square root and then square. Square root and square. They happen at the same time, so they're going to cancel out. And we're going to get x plus 5 is equal to 16. All right, so we square the left. 4 squared is 16. Now we solve. And we get that x is equal to 11. And then we check. So we plug 11 into our original equation. And we get square root of 16 is equal to 4. And yes, that's true. So yes, that is definitely the right answer. I should go back over here and throw this one out, right? Okay, so that would be DNE. Okay, so you square or cube both sides and then solve for the answer. That's the basic plan of attack.